Right, guys. Internet looking a little bit shaky. I'm trying to see if I can just sort that out. So which one of these can give me the best signal? About 4 different Wi-Fi sources. Trying to see which one will work best. All right, we are at day 4. We are at day 4 of this thing. Exam is the day after tomorrow, but it should be ready. So we're just gonna do this last little bit. You see, it's not coming up on the thing. There's a delay. And the students at home, can you hear me and see the screen? Still about delay. Let me break it. Let me break the share and start it over. That's slight delay. All right, let's work. So objective today is to get through these 2 last topics. Relations, functions. I think I want to do some vectors and trigonometry. 4 hours. We'll start about half an hour late. We're actually about 45 minutes late. Still have to do after do. So if we go past 8 o'clock, so it be so be it. All right? 9 o'clock we're supposed to go tonight. Okay. So if we go past that time, so we have to do that. All right, so let's get kicking. We know what it's about. It's about doing these questions and getting ourselves familiar with them. You should be familiar with all these questions, but just in case of an issue with how to work out a question, I'm just going through them with you. If there's something that you don't understand, you let me know. Students online, same thing goes for you. All right, so we're gonna go do these functions. I'm on the pages 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And not all the pages are full. So we should be able to get through these fairly quickly. Then we'll look at the 2026 paper, 2025 paper, 2024 paper, break, and then we'll come back and do that one. I might just run into the vectors after this one. All right, because we have not yet done vectors. All right, let's go. So we're doing functions, relations, and graph. Relations, function, and graph. Given that y varies directly at x as a direct variation, and y is equal to 19 when x is equal to 152, which of the following equation represents the relationship? So what it is that we're going to say y varies directly as x. It means that y is equal to a constant times x. And what it is, we're going to use the square of values to get an expression for the constant. So based on this, if you divide by the x, the constant is going to be y divided by the x. That's what the constant is going to be. Using these values, the constant becomes the y is 19 over 152. And so this equation now, this relationship becomes y equals 19 over 152 times the x. All right, and the question is, which one of these is 19 over 152, 1 over 8, or is it 1 over 131? No, it can't be that. All right, so basically that becomes a relationship. 19 over 152. And it's 8 times. So 19 to this goes 1 time, 19 to this goes 8 times. So it's this one. Y equals 1 over 8 times x. This is it. All right. Simple as that. So it was inverse variation. If the change this word to inversely, you have to put y equals k over x and do the same thing. Use these values to find the k and then write back the equation. Okay? That is it. Let's see what the next question is. This one says the distance L that an elastic string is stretched by hanging an object of mass m varies directly as the mass of the object. That's a direct variation. So the L is directly proportional to the mass m. Where's the mass? The mass m. That's what that means. So the relationship is that the length is k times the mass again, just like the other one before. Those are the two variables. Then it says, if 5 kilograms, that is a mass, when the mass is 5, of an object, the string is 31 centimeters. The length becomes 31. Let's read it carefully. The distance L that an elastic string is stretched by hanging an object of mass m varies directly as the mass of that object. If 5 kilograms, this is the mass. If a 5 kilogram object stretches the string 31, that is the length, how far will 29 do? Stretches the same thing. So basically, how it is like this. You can do it by finding the equation again with the k, by finding the k, plug these values in here, and get the k. I can do it like a proportion, because what happens now is that they divide by the L, you see that the k is equal to the length over the mass. So the length over the mass is a constant. The length over the mass is a constant. All right? So, I'm going to do it over here. So the length over the mass is a constant. Let me put this up here. So this is a constant now. Length over the mass is a constant at all times. Right? This is the information we're going to use. Right here. So the length over the mass is a constant. Then the length over the mass for this pair equal the length over the mass for the pair that you're trying to find with that 29. Right? So we can set up like this. The length of 31 over the length of 31. Sorry, my mistake. The length of 31. The length of 31 over the mass of 5 is equal to the length that you want now from here, so let's call that L over the mass of 29. That's what they kind of working with. That's what they're working with. I can literally estimate it because these values are wide enough so you can estimate it. So you can estimate this maybe as almost 30. This is approximately 30, this one. So it's almost like 6 times. It's almost like 6 times this. All right? Because if you want to find the L, you multiply the 29 up here now. All right? So the L that you want would be 31 over 5 times the 29. You multiply the 29 up here. So look at this now. In the exam, I can't work it out. This is almost 30, you know. Right? That's almost 30, right? 30 divided by 5 is 6. So the value that you want is approximately 6 times 31. But actually less. This is the closest value to 6 times 31. 6 times the 30, 180, 181. But remember, this value was less. So looking for a value close to that. You don't have to actually work it out. But I could work it like this. This value is approximately 30. This one is approximately 30. So God said the L is approximately equal to 31 over 5 times changes to 30. But we know it's going to actually be less than this because I will increase that to 30. Just to make the calculation a little bit easier. And then you're going to say, okay, 5 into this goes 1 time, 5 into that goes 6 times. 6 times 31 would be 186. Right? But it's actually 6 times 29, you know. So it's a value less than 186. close to 180. This is the one that it has to be. Right? That is it. So I would know that that is the answer right here. Because this value is almost 30. All right, so the value like that to go. So it to be 31 times 29 divided by 5. Yes, that is the correct answer. All right, that is the correct answer. 179. All right, that is the correct answer right there. This here now is our inverse variation. This one says, given that y varies inversely as x, this means that y is equal to k over x inversely. Multiply the x up here, so now you get the xy is a constant. What that means? The product of x and y is the same all the time, the constant. Right? The product of x and y is the same value. For any period that you have, the product of the x and the y is the same. It says when y equals 6, y equals 16, x equals half. It means that the k is 8, right? It means that half times 16 is equal to the k. So the k is equal to 8. If the k is equal to 8, they say, which of the following equation represents a relationship? The k is equal to 8 up here, so. So from that now, this equation becomes that y is equal to 8 over x. Sit down there, so y equals 8 over x. That is it. Very good. So you set up the relationship, use the value that they give you to find the k. Some questions they don't need to find the k, as I did up here. They not need to actually work out the k. Just know so up here, so the k will always be equal to this. If down here they gave us some value to calculate, I would use that the product of the numbers is the same all the time. It's a constant. So the product of one pair equal the product of another pair of x and y. That's what you do. All right, that finishes that one. Let's take up here. This one says the point to a line where linear functions crosses the horizontal axis. I don't know if this is function or coordinate geometry. The horizontal axis is the x-axis, don't it? So that is the x-axis intercept. So this thing that really, really behind by far. This is the x-axis intercept. The device is behind by far. Online. They are behind by far. Let me try something again. Pause this until they are behind by far. The thing. Students online, can you hear me? Answer the screen, what's happening?
Yes, sir.
What are you seeing on the screen now?
Question 26.
Huh?
Question 26.
Still seeing question 26, but I'm talking about something else, right? So the video is lagging. You're not seeing me on question 45 right now.
No, sir.
Yeah, this thing is bad. This thing is bad. Let me try a different. The internet is bad. Let me try. It's lagging badly. It's lagging badly, 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 badly. Let me try my data as this thing is very poor. So let me try it without financing. It's very, very poor. Let me stop share and start share again. Let me just try and see if we can bring us back in sync, as this thing is horrible. Let me try hotspot. Try hotspot this thing. Get a better of it. Internet is horrible. Still lagging everything. It's lagging badly. Stop sharing. Internet is poor, guys. It's line. It's a line problem. Can't do anything about it. It's a line problem. Huh? Flow? Yeah, it's very poor. It's very, very poor. All right, let's see if we're making any headway. It's just lacking badly. It is lacking badly, badly, badly. All right, let's go. It's a little bit better than before now, though. All right, so the point where a function crosses the x-axis is the x-axis intercept. That's what it is, the x-intercept, all right? The point where a function crosses the vertical axis, you know, understand this time is a vertical, that's y-axis. That now is a y-axis intercept or y-intercept, this one. So you see the kind of ask these questions, you have to be careful, right? All you have changed is the word horizontal to vertical in this question. So we have to be careful. All right? Down here. This one says the equation of a line which passes through the point 0, 5, and at a gradient of 4. Easy question. It's y equals mx plus c. I'm going to give it a point 0, 5. It means that the c is equal to 5 right here. And this is the gradient m. And so putting them in this equation. So the equation becomes y equals, the gradient is 4, x and the c value is 5. That's the answer, 4x plus 5. Oh. All right, that is that. Next question. It's like some, when you get into the functions part, it's coordinate geometry. A line L is parallel to this. So the line parallel to it is at the same gradient. Parallel lines have the same gradient. They could have changed this word to perpendicular on the same question. Notice a parallel, they have the same gradient. Find the gradient, we need to make y alone the subject of this equation, right? So this equation, I'm going to write it firstly. I'm going to transpose I can transpose the 3x over here. And I note I'm going to get 7y, negative 7y, negative 7y equals negative 3x. Take the 9 and carry it over as well. I get positive 9. Then divide by negative 7. Dividing through by negative 7. Negative 7. I divide through by negative 7. This becomes y. This becomes negative 3 over negative 7x. This becomes 9 over negative 7. This right here now is a gradient that I want. This thing is the gradient that I want. The m. It is negative 3 over negative 7. The negatives cancel to give you 3 over 7. So the gradient is 3 over 7 right here. All right? Could have done it another way, but that is it. Key thing, you have to get the line in the form y equals mx plus c. Y alone must be the subject. Y equals mx plus c. When it is in that form, the y alone as a subject, then this becomes a gradient. That's what you want. If the question instead asks for the y-axis intercept, it will be 9 over negative 7. This one, or negative 9 over 7. This will be the y-axis intercept, this one. If the question asks for the y-axis intercept instead, which they can ask you. All right? Here we go again. This line is parallel to this one now. Line L is parallel to that. Again, they have the same gradient. What's the gradient of it? Same gradient. Parallel lines have the same gradient. So again, I'm going to write this equation in the form y equals mx plus c. Y equals mx plus c. Let's do it another way. I'm going to take the 5y and carry it over on the right side instead. So this equation, I'm going to write it as 2x minus 8 equals 5y over there. Okay, over the negative 5y, make it positive. Then divide 2 by this 5 to get y by itself. So I'm going to divide by 5. divided by 5 now, this becomes 2 over 5x minus 8 over 5 equals the y by itself. This can be spun around. It is the same as, i.e., this is the same as, let's put it here, y equals 2 over 5x, 2 over 5x minus 8 over 5. Again, this here is your m, your gradient. This is your gradient, m. All right? And so it is 2 over 5. Next question again. This time the our line is perpendicular now. Say change it. A line is perpendicular to this line. So perpendicular lines have negative reciprocal gradients. So what is the gradient of line L? The negative reciprocal of this. If this gradient is M or M1, this gradient is M1 equals 2 over 5. Then M2 is minus 1 over M1 or ML then, line L. Gradient of the line L is minus 1 over gradient of line 1. This calculation can be done quickly by flipping this one and changing the sign. Flip the 2/5. It's going to become 5 over 2 and then change the sign to a negative. It is positive right now. Change it to negative. So it become negative 5 over 2. Negative 5 over 2. See it right here, so negative 5 over 2. Flip the gradient that you have and change the sign. And you get the perpendicular gradient. All right? So this line, they give this line a different question. Look, different question, they ask the same thing. But they give this equation instead. Y equals 3 over 7x. What is that? Plus 9. It's going to become negative 7 over 3. So the answer would be this one. Negative 7 over 3. This one here, this is negative 7 over 3. So for this one, the perpendicular, if it was this equation, the perpendicular gradient would be this one. It was the same question. And a different question, we gave this equation instead. And this is the answer down here. Right? So you're flipping this and changing the sign. Negative 7 over 3. All right, so that is that. Next question up here. This one says, what is the gradient of this straight line? You won't put negative 3, you know. Remember, you have to get rid of this 2 first. I have to have y alone as the subject. So you have to divide by the 2 first. So you take this equation and you're going to divide by 2 to get rid of this 2 beside the y. And when you divide by 2, it's going to become y equals, divide this by 2, it becomes minus 3. It becomes minus 3 over 2. Minus 3. Hello? I'm in a class now. What do you want? Go. What's up? What's up? Huh? 28 what? 28. You need it right now? Because I'm in class. Oh, all right. Send me on WhatsApp for you. The material number and everything. See me can give you. Send me on WhatsApp. Yeah, because I'm in class, right? Yeah. What? That's actually work. Want to do something on the computer. All right. This one says, what is the same line? You know, so because it's the same line, that's the same equation, it still works out to be y equals minus 3 over 2x minus 4. So the y-intercept becomes this negative 4 right here. That is your c value. Over here, the gradient is minus 3 over 2 right here. So you see, on a different exam paper, they asked it something different for the same line. Very good. All right. Next question. Here this one says, they give us that diagram with that straight line. The straight line cuts the y-axis. That's right here. That point is 0, -2. 0 is the x value, -2 is the y value. 0, -2, right here. X value there is 0. 0, -2. All right, next one. This one says, give us that straight line again, and it says, what's the gradient of the line? The gradient of AB on the graph is what? So we just need to count the rise and count the run from here to here. Count the rise and count the run. Make sure that each grid is 1 unit, which it is vertically. Each grid is 1 unit horizontally. So counting the rise and counting the run to go from A to B. So the rise is this to here. It's a rise of 2. And then you count the run. 1, 2, 3, 4. 1, 2, 3, 4. The run is 4 units. Run 4. So rise 2, run 4. So the gradient is rise 2 over run 4. 2 over 4 is a half. 1 over 2. So the answer is this one. All right. Next question. Which of the following pairs of lines are perpendicular? So remember, the perpendicular lines are the ones where the product of the gradients is -1. When the product of the gradients equal -1, they are perpendicular. So let's see to look at the gradient of each of the lines. So for this one, if you divide by this 2, you're going to get -3/2. So let's look at it. This line, if you transpose it and make y the subject, you're going to get y equals -3/2x minus divided by 2 as well, get 4. So this is the gradient of this one. But this one, if you make y the subject, you can take the 2y, bring it over here first, and then you're going to divide it under the 3. So for this one, you will get y equals 3/2x, and this will come over and become a +8, and divided by 2 as well, it will become a +4. So these two gradients, when you multiply them, you don't get -1. So those are not perpendicular. Right? Right here, so the two gradients are the same. So they are parallel. These two are actually parallel. Because they have the same gradient. Right? So they are parallel. Let's see, what about this one? For this one, the gradient is -4. See, the gradient is -4. To get the gradient of this one, we need to divide by this 4. So we divide by that 4, this one will become y equals 1/4x plus 1/4. So this gradient for this second one, let's call it M1. For this one, second gradient will be 1/4. If I multiply these two values, they become -1. So that's two gradients. So for this one right here, M1 times M2 is -1. -4 times a quarter is -1. So these are the perpendicular ones. Those two are perpendicular. So looking for the one where the product of the gradient is -1. Those are the perpendicular lines. But the product of the gradient is -1. All right? Down here. Which of the following is the equation of a straight line? A straight line equation can be written in the form y equals mx plus c. So in this now, you don't have no products or quotient or power of the x and the y. So this is not a line because it is a product of x and y. This is not a line because it is a product of x and x, so the x squared. This is not a line because, again, it has an x squared terminus. So the line is this one. Can be written in the form y equals mx plus c. If you have about the 3, it becomes y equals 2x minus 3. All right? That is the line. So look for the one that does not have any product are quotient of the x and the y values. So it must not have any xy, must not have any x squared, must not have any y squared, must not have any x over y, not like that. Right? For it to be aligned. The x and the y values have to be separate and linear in the equation. Which of the following represents the equation of a line again? Again, it can't be this one. Look at it. If I take the x and divide it up here, I'm going to get xy equals 4. That's not it. I'm come to the class 8 and this paper class. This one has an x squared in it? No. Remember this one. This one can become xy equals 4. So you end up with the product of x and y. You don't want that. This one has an x squared. You don't want that. This one has an x squared. So none of these are lines. So this is the line again in the form y equals mx plus c. Obviously, right? Obviously, y equals mx plus c. Again, you're looking for y equals mx plus c. Line in that form. All right, that can be written in that form. All right, that one done. Still not doing no functions here. Functions now, ready. Functions now. This question gives us this diagram and it says the relation that best describes the mapping diagram is what? This one is that one. Many to one, don't it? Because you have two values, for example, here mapping to the same one value up here. See? That's many over here mapping to one over here. So that is many to one. And many to one relation is not a function. Yeah, it can be a function. So one to many, that can be a function. Right? Once you map into one, it can be a function. So it is many to one. So one to one or many to one can be functions. Right? It can be functions. This one down here gives us this, h of x equals that, and asking us for h of negative 6. Just take negative 6 and plug it in here for the x and work it out. So it will become 3 times negative 6 minus 2 divided by 5. That's negative 18 and negative 2, that's negative 20 divided by 5. Negative 20 divided by 5 is negative 4. So the answer is this one up here, negative 4. That is it. All right. Then we have another one here now. Same function they give us, but this time they want h of 4. Again, I'm going to take the 4, plug it in there. So it's going to become 3 times 4 minus the 2 divided by 5. 3 times 4 is 12. 12 minus 2 is 10. So it becomes 10 over 5. 10 over 5 is now equal to 2. So this value now, therefore, becomes 2. All right? That's an easy stuff. Functions are easy part. You should enjoy functions on the multiple choice. Same thing here again. You want g of negative 6. Put the negative 6 in there. So it's going to become 7 times negative 6 minus 3 divided by 5. 7 times negative 6 is negative 42 minus 3 divided by 5 become negative 45 divided by 5, which then become negative 9. 45 over 5 is 9. Negative 9 right here is the answer. All easy stuff so far. So here, they give us that mapping diagram and say, which of the following best describe the function? And so actually the first one, the y value, look, the y value is 3 more than the x value every time. You can see it. See, this value is 3 more than that. 3 more than that. So you're adding 3 to the x value to get the y value. See? So the y value is the x value plus 3. So that's about this one, the first one. Relatively easy. You gotta put that the first one. But all right with that, straightforward. All right. This one says the value of what is the value of f to the minus 1 of 1 if given that f of x is equal to this. Now, for this one, you can actually try values in it. But watch this. I have the answer down here. You can actually try these values in this and see which of them give a negative 1. Give it a 1. Watch this now. The one f to the minus 1 of negative 1. Pay attention. So this is the function that they give us. And this function is f of x equals 5 minus 2x, right? Write it like that. And now we're trying to find f to the minus 1 of 1. What I'm going to do here, to do it quickly, I'm going to put it equal some number. Right? F to the minus 1 of 1 equals some number. Therefore, 1 is equal to f of that number. So if I'm in the exam, I can try these values in here and say which one of them equal 1. We'll put it in. We'll put in 1 in this. I get 5 minus 2, which is 3. That won't work. Put 2 in this. I get 5 minus 4, which is 1. So the answer is this one right here. So whichever one of these values going to give me 1, we'll put it in the function, is the answer. That is it. In the exam, I could do that. But otherwise, you can finish this by putting now 1 equal f of n. So you're going to put n in this. So you're going to get 5 minus 2n. So you're going to find the n that makes this equal 1. You can continue like this. So you can do q over the 2n and q over the 1. You're going to get 2n equals 5 minus 1. 5 minus 1 is equal to 4. You get 2n equals 4, which therefore means that the n is equal to 2, which is the same answer that I have here. But from your reach right here, so that's okay. Which are these values? We plug it into this function. The result is 1. And by trial and error to be the second. Right? Nice and easy. Down here, which are the following best illustrates a function? Somebody talk to me. Is this one a function? Stop one. Why not? Why is this one not a function? This one. First one. The domain. The domain. So all these values must map. And when they map, they must all map one time. So there are 2 values here causing that this not to be a function. This one don't map. That makes it not a function. And this one map twice. It must have 2 hours coming after. So those are the 2 values that are causing this one to not be a function. Remember, it is the domain that decides a function on the domain. All right? What about this one? Is this one a function? Huh? Why? This value is mapping twice. This value is mapping twice. All right? So that makes it not a function. What about this one? Well, all 3 of them causing it have to be a function. That one not mapping. This one mapping 3 times. And this one not mapping. So all 3 values causing that this not to be a function. For it to be a function, each value in the domain must map. Every single one of them must map. And when they map, they can all map one time. And so the answer is this one. You see it? This value is mapping one time, which is good. This value is mapping and it's mapping one time, which is good. This value is mapping and it's mapping one time, which is good. Doesn't matter how the mapping end up over there, you have a function. So this one is the function. But okay with that? Very good? Over here. This one says, the set of ordered pairs below represents a relation that is a function. Which are the following points, when added to the set, would form a relation that is not a function? Remember, it's not a function if it becomes a one mapping to many. Becomes one to many. Is no longer a function. So each of the x value must map to only one y value for it to be a function. If it is a one to many, it is not a function. So anybody where you add to it, right? It can't be that you end up where you have a domain value mapping to more than one value. You get me? So look at this now. Suppose I add this one to it. Would it still be a function? If I add this to up here, so, and this join this, suppose this join this set of values up here. Look at it this way. If this value joins this set of value and I extend it to 2, 8, Would that be a function? Would that be a function? If I add this 2, 8 to this set of values, would everything now still, with all of them still be a function? Okay, say no. Which are the following when added to these sets would result in a relation that is not a function? Look at the first one. If I add the 2, 8 to it, would all of these 4 now form the values in a function? You're looking for this, you're looking for this thing, you're looking for having a 1 mapping to many. You can't see it, man. Looking for the domain values, that's what the domain values map to. You know, see the 2 are mapped to 7, and the 2 also are mapped to 8. That is what would happen. If you add that to it, you have the 2 mapped to 7, and you also have the 2 mapped to 8. See that? If you add this to it, this is the one that you cannot add to it. Because if I add this to it, you're going to have 2 mapped to 7. Yes, so. I also going to have the 2 mapping to 8. You can't have that. That's why that would make it not a function. If you put 2, 8 in it, it's no longer a function. If you put 1, 3 in it, good, because they never have no 1 in the domain of in the first place. Right? If you put in 0, in other words, the point that you're putting in, you can't have any repeat of the domain. You can't have the domain value again. Because the domain must only map to 1 value alone. Huh? It's a domain that decides a function or not. Look, what decides if you have a function or not are these values. The domain. You don't want to be repeating this any of these values in the setup here, so you don't want to put no other point that those values are repeating the domain values. You get me? Because you cannot have a case where a domain value is mapping to 2 different values. But that will be a 1 to many. For it to be a function, you cannot have a 1 value in the domain mapping to more than 1 value in the codomain. So you can't have 1 to many. This way you must not have. You must not have 1 to many. So any point we put in, add to this. You can't have the same x value as 1 that is already there. So since me already have a 2 upon x value here, so I cannot go and add this point to it with a 2 here so as well. I already have the 2 mapping to a value already. So I can't go make the 2 map to another value. You understand that? Look at it carefully, guys. You cannot have a case where a value in the domain, an x value. Your x values cannot map to more than 1 y value. If I add 2, 8 to it, to this set, if I take 2, 8, if I take this 2, 8 pair, and I add it on up here, so see this up, I have it right so. Then you have 2 mapping to 7, and I also have 2 mapping to 8. You cannot have that. 2s are domain values. It don't matter what with the y values, you know. All you know is that the domain value cannot map to more than 1 codomain value. You cannot have that. Otherwise, it's not a function. So that is the period that I cannot add to it because I cannot set it up so that I have 2 domain values. I have the same domain value mapping to 2 different codomain values. So this is the one that I cannot add. If I add that to it, it is no longer a function. If I add that to it, it is no longer a function because it becomes a 1 to many. I'm not sure you understand this. Let's continue. It's the same question here. We're looking for again. Which are the following points, when added to the set, would form a relation that is not a function? Look at that. C. Okay, you cannot add a point to have already have a domain. You don't want any domain values where I have already to come back. You understand that? That is the point. Good. So you cannot add C. Beautiful. So like gonna get to it. So you cannot add this one. Because you would have -2 mapping to 7, you have -2 mapping to 8, which would not be a function. That would be a 1 to many, which is not a function. All right, good. Let's continue. Which are the following points that lies on this line? So to find a point that lies on that line, screw the last one, don't it? Like the last one is the y-axis intercept. See there? This is already in the form y equals mx plus c, you know. So we see this value. Right? See this value. The c is equal to -3. Means that the pass to the point 0, -3. And they give it to you right here. But if they didn't give it 0, -3, how you could find out which point is on the line? Because when you plug in the x value in the equation, you're supposed to get the y value. See that? See it? If I point it on this line, it means that the coordinates satisfy the equation of the line. When you plug the coordinates in the equation of the line, the equation stays true. So in other words, because this already have y as a subject, it means that if I plug in 2 here, so for example, I get 2 is 4, and 4 minus 3 is 1, but this y value is not 1. So you know, so this point is not on it. This point is not on it because it does not satisfy the equation of the line. Get me, guys? So this is the last one. That's actually the y-axis intercept. Because I take the 0, I'm going to plug it in here, and the y is equal to -3, which is what it is here, -3. That's actually the y-axis intercept. Next question. If we will start function and I want f of -3. So we're going to plug the -3 into this. So we're going to get 2 times -3 squared, because the x cube become -3 squared, minus this 1 now, -1. Now the -3 squared is a +9. So this barely becomes 2 times a +9 minus 1, which then becomes 18 minus 1 is 17. So the answer for this one is just 7. All right. Let's continue. This one says, item 45 refer to the following arrow diagram, mapping diagram. The arrow diagram above describes a relation. What relation? Let's look at it. All right, so these are bigger than these, which are the elimination. There's a process of elimination. It says y is less than x. That is not true, don't it? This y value is actually greater, don't it? So this one is not it. It's a process of elimination. It says y is a factor of x. Are these y values factors of these? No, they're actually multiples, don't it? They're bigger. So it's not true. The y values are not factors. They are actually multiples. Next one. X is a factor of y. X is a factor of y. That looks more true. Let's look at it. 2 is a factor of the 8 and the 10, which is true. 3 is a factor of the 9 alone, which is true. 4 is a factor of the 8 alone, which is true. Yes. So the x values are factors of the y values. So a question like this is go down and use a process of elimination. This is the answer. This one says x is a multiple of y. Again, that is not true. 3 is not a multiple of 9. When they mean a whole number multiple. It's not. Right? So this answer also is not right. The last one. And by a process of elimination, we come out with our answer being the third one. All right? This question down here. Another mapping diagram. Same thing again. You notice the same question alone. But look what them do now. Them switch around these values and put them as the output values. See? See that? And these output values, these y values, have now become the input x values. So same values. So you see again, kind of process of elimination to see which one is the correct answer. All right. So this one says y is more than x. Not true. Because these are actually less than these, right? So this one is not true. It says y is a multiple of x. Y is a multiple of x. No, it's more a factor. Right? Those small values are not multiples. Right? They're smaller than the x values. So no, this is not right. It says x is a factor of y. X is a factor of y. That's not true either. X is not a factor of y. Factors are usually smaller, right? Like 1 and number and so on. So those are not factors. This is also not true. X is a multiple of y. Yes. These are multiple of these. So yes. This is the one that is correct, the last one. So it's a similar question that they gave on a different paper. Same two sets, just had to switch them around. That is it. All right, there was some number line. Which of the following lines represent this? Look at it carefully. So you're not including the -2, so you put an open circle on the -2, and you're going up to 4, including the 4, because the equal is on the 4. So you go for an unshaded circle on the -2. So right away, you know that these two out of it, right? And they're looking for a shaded circle on the 4. Because the equality, they're looking for a shaded circle on the 4. So a shaded circle on the 4 and a shaded circle on the 4. But this is the one. All right, so I'm just exiting off the one that I don't want. So I want a shaded circle, so I don't want this. I don't want this. I already don't want this one. So the answer must be the one that I didn't X off anything. See, this is the last one. The yes. Open circle on the -2, shaded circle on the 4. And you want the interval there. So sometimes I think I explain too much now, necessarily. This one, because we got it done. This one says, show the number line. So the graph of the inequality is what? So you notice it's an unshaded circle on the one, don't it? So you notice the less than thing. You're going to the left, the values over here are less. So the less than. This is a less than question. Less than. X is less than. Square value is 1. So it has to be this one, right? They can change it and shade the circle in the guys. Then answer would be this one. Because you know, including the 1. All right, it's a shaded circle, it becomes that. All right, but that is it. Very good. Over here, give us this graph. Check this graph a lot. They ask us for the maximum point. Maximum point is right up here. Coordinates of this point up here. Look at it. It is 2, 4. That's the maximum point. You must familiar with this question. The maximum point has coordinates 2, 2, 4. Number 2, 4. This is it. This one said the equation of axis of symmetry. They give the same graph, and all want the axis of symmetry. Axis of symmetry is this blue line passing through the turning point, coming down here, and pass through 2 as well. That's the axis of symmetry. So it's a vertical line passing through 2, so it's x equals 2. Right? X equals 2. So this is it, x equals 2. That is it. Next one. This one said the values of x at the point where the curve cross intersects y equals 0. Now, what you have to realize about y equals 0, guys, that y equals 0 is actually the x-axis, right? So that's the key thing with this one, that the y equals 0 is actually the x-axis. So they're asking for where the graph crosses the x-axis, which is now at this point at the origin, at this point at 4. See that? Right? X equals 0 and x equals 4. 2 points x-axis, 0 and 4. See them here? Another question on it. The value of x at the point of the graph intersect the x-axis, same thing. X-axis again. Alright? X equals 0, x equals 4 again for this one. This one. Which of the following equations represent a straight line? This is a number 10. This one right here, right? Straight line equation. So what questions repeated? Straight line. That are not straight lines. Up here, it says which of the following sets is represented by the function f of x equals x squared plus 3. So this really is f of x equals x squared plus 3. So you can look at this. You plug in these values in this function, x squared plus 3. Let's look at them. So the 0 will become 0 squared plus 3, which is 3, don't it? So 0 map into 3. That's why you have 0 map into 3 in all of those. Then the 1, if you take the 1 and plug it here, so it becomes 1 squared is 1, 1 plus 3 is 4. So this one is mapping to 4. So 1 map to 4. So you know, say this answer, so you say this out of it, and this out of it. So that this answer or this answer. So we can just look what the 2 does now. So the 2, we take the 2 and put it here, then become 2 squared is 4, 4 and 3 is 7. So the 2 is mapping to 7, which now then is this one. 2 mapping to 7. So that's the last one. You get the 0, 1 mapping to 4 and the 2 mapping to 7. So the answer is this one, don't it? That is it. Next question. Now they give us x cubed. So for x cubed, the negative 2 map to negative 2 cubed. Negative 2 cubed is negative 8. The only answer down is where the negative 8 is this one. So this must be the answer. You have a negative 8 in the range. So that is the range. But negative 2 maps to negative 8. And this is the only one with a negative 8. That has to be the answer. All right. Same here now, them have minus x squared. You have to be careful with this one now, guys. Because this minus not squaring, you know. You're only squaring the x squared. So all the values will end up negative. So for example, this negative 2, you got to map to negative 2 squared. This negative not squaring. You only squaring negative on the 2. So this instead becomes a 4. So it's become negative 4 in the end. So these 3 values with negative 4. So based on the fact that these 3 values are negative 4, it don't mean the same miracle the second value, which is where you get to the 1, with the 1. Right? But we know so we're getting a 0, don't it? Right? We're getting a 0. So plug in the 0 in this, it is going to become 0. So 0 maps to 0. So the answer is the last one, 0 maps to 0. This one maps to no, that's not it. That's not it, you know. That's not it. So so you have to repeat values. Because what happens is that you can't get a positive value in the answer, no, guys. This will always come out negative. Be careful. Because you're only squaring this negative, this square. So all the values are going to come out negative or 0. See what I'm talking about? So maybe the safe thing to do is actually work out all of them. So see here, it's negative 1. If you plug it in there, it's going to become negative 1. Because you're going to get negative 1 squared, which is still negative 1, because negative 1 squared is a positive 1. If you plug the 0 in there, you're going to get 0. So this one maps to 0. But if you plug the 1 in there now, you're going to get negative 1 squared. The negative squared not on this negative. It's only on the 1. So it becomes negative 1. So this one also maps to negative 1. And this 2 also maps to negative 4. So the domain values, even though the negative 4s are repeated and the negative 1s are repeated. But this negative 4 and this negative 4 repeated, it can all appear in the set once. So you know, say I have negative 4 in this. So this or this in there. But these out of it, okay, you cannot have any positive value. None of the answers are positive. So those out of it. So the answer is only B, as in boy. But after that, all right. Remember this one, guys. We'll put a negative out here, not square, not negative. That's not on the square. Then we put negative x all squared. that difference. I wouldn't make any difference. But negative x r square same as positive x r square, because square the negative anyway, so it don't matter. Alright. Anyway, let's continue. This one. Which of the following is a graph of a linear function? A linear function. You know, it's one of these two, don't it? Because there are two lines. Right? So which one I think it is? This one or this one? Which of them is a linear function? Which of them is a linear function? That one or that one? All right. The first thing you need to make sure first one you need to know which one is a function. And then it is linear. How do you know what a function is on a graph? Vertical line test. Remember this thing. Vertical line test tells you if it's a function or not. Come on, man. How much part we're going to do the same question and still don't know? The first of same question come how much paper already wanna do? Wanna don't know this? I'm gonna go to the solution for this and multiple papers, the same solution. This is not a function because if you put a vertical line on it, it will intersect it at multiple points. So it will fail the vertical line test. A function can't have no vertical section on it. So that's not a function because if you put the vertical line on it, it will fail the vertical line test. So this is linear, the line, which is not a function, not a function. Because if you do the vertical line test like this, a vertical line cross it several times. So it's not a function, that's a V-line test. It fails the V-line test. Fails. Fails. Fails the V-line test. That's what happened. This one pass the vertical line. The vertical line is at 1 point intersected. The vertical line is at 1 point. So that's a function. Because any vertical line I draw, it can only intersect the graph at 1 point. So it's a function and it's also a line. That's what a linear function. Linear function. See it? So this is the answer. This is a vertical. It's a linear function. It's a line. It's a function. What about this one? What kind of function is this? Is that a function or not? Is that a function or not? Yes, because any vertical line I draw can only intersect at 1 point. See there? That's why you know it's a function. It's a one-to-one function or a many-to-one function. Or you decide if a graph is a graph of a many-to-one or a one-to-one function. You do the horizontal line test. So the vertical line test is to tell you if it's a function or not. The horizontal line test is to tell you what kind of function it is. Right? So this is a function because it passes the vertical line test. The vertical line test pass the V test. So you know it's a function. The vertical line test tells you yes, it's a function. What kind of function? Is it a one-to-one function or a many-to-one function? Then you do the horizontal line test. And in horizontal line cross at all 1 point, meaning it's a one-to-one function. So this is now the H test or the H line test, horizontal line test. Intersect at all 1 point, and therefore that's a one-to-one function. Which occurs a non-linear one-to-one function. That's what this is. And not a line. It's a non-linear one-to-one function. That's what this is. What about this one? Is that a function or not? Function or not? Eh? First, that's a quadratic function, guys. Don't say a smile graph. Quadratic function. When you realize that a quadratic function, that's first thing. And why you say no? Because I draw a vertical line test. Remember, I always say do the V test first. The vertical line before the horizontal line. Look, any vertical line I draw can only intersect this graph at one point. You know, see that? Any vertical line I draw can intersect the graph at only one point. Why did you say no? It's not a guessing thing, guys. You want to know the function or not, draw the vertical line for it. If any vertical line can only intersect the graph at one point alone, then it is a function. You don't want a vertical line to cross it more than one time. Because if you have a graph looking like this, for example, like so. So remember a graph looking like y-axis, x-axis. If we do a vertical line right here, it's going to cross that 2 points. You know what that means? It means that the same one x value, for example, 3, is mapping to two different y values, like 1 and 5. That's what that means. You may say I have a point 3, 1 on it. I have a point 3, 5 on it. Same thing we say whenever I want. That's 3 mapping to 1 and 3 mapping to 5. That will be a one-to-many, which is not a function. That's why we do the vertical line test. The vertical line must cross the graph at only one point. Come on, man. Exam is there for tomorrow. What am I doing? Let me leave this on the screen. So this is not a function. This one would not be a function. This one down here. Not a function. Not a function. Come on, man. Let me send space and repeat all the time. You can't do. So this is a function. What kind of function is it? This one. What kind of function is it? Many to one. Because I'm going to do the horizontal line test now. It crossed at 2 points. Why that is many to one? Because look. Two different x values. The x value over here, so, and x value over here, so. Two of them give it the same y value. So that two different x values give it the same y value. So like, for example, you have 3 right here, so, and -1 this, so. And the two of them are mapped to, for example, a value of 5. Right? So that's many to one. That's a many to one function. But also do the horizontal line that intersect at more than 1 point makes it a many to one function. So horizontal line test tells you what kind of function it is. After it decides the function. It is a many to one function using the horizontal line test. So this is the H line test. Intersect at 2 points. So we know it's a many to one. Okay. To one. All right. What else? Look at these now. Which of these are functions? Which of these are functions? Which of these are functions? Huh? You say B. Anybody else? It can't be B, my boss. Look. It's 2 points right there, so. All right, stop talking. Hey, stop talking. Those points right here. Look, no, look, no. All right, all right, all right. See, there's some draw a vertical line here. It's gonna cross the graph at 2 points. And here things same way. To the points of here, so cannot have any vertical section on a graph, guys. Otherwise, it's not a function. You draw a vertical line here again. Pass through these 3 points. Fail the vertical line test. But this one again, not a function. Because of all these points down here, I put a vertical line through those points to intersect more than once. So those are not functions. Got this one. Any vertical line I draw can only intersect the graph at 1 point. See them there? One here so, one there so, one there so, one there so. So that is a function. What kind of function is it? Many to one or one to. Eh? 1-to-1. Yeah, because I draw a horizontal line, that's a 1 point. We draw a horizontal line, yes, so 1 point. Anyway, I draw a horizontal line, can only intersect the graph at 1 point. So this one will be a 1-to-1 function. This one is a 1-to-1 function. That is it. 1-to-1 function. This one says, what is the value of the point of intersection of the system of equations? This and that. So you see, whenever f of x equals 3 is the same as y equals 3. This one is the same as y equals 3. G of x equals that is the same as y equals 5 over 2x plus 1. They're solving that. Right? It says, what is the x value you want? The x value alone you want. So you can eliminate the y value. So you basically need to put this equal to 3 up there. So the y value is the same. So you're going to put 5 over 2x plus 1 equals 3. Subtract that. You're going to get 5 over 2x equals 2. You multiply by 2, you're going to get 5x equals 4. You divide by the 5, where x equals 4 over 5, which is 8 over 10, which is 0.8. 0.8. So that's simple as much as equations, really. All right. And then we come down here. After this, I'm going to do the thing. I'm going to bring up the screen with the next, with 2026 people. Give you a couple minutes to run through them while I do something for work, right? This one said, a parking lot charges $1 plus 25 cents. This is 25 cents for every hour each or part thereof in which a vehicle is parked. Function C of H that represents the parking cost is which one? So the fix $1 first. Fix $1, so that this or this. And then multiply the hours by the 25 cents. If you multiply the hours by the 25 cents. So to get the total cost. So this basically is the answer right here. All right. All right. So that finishes that. Let me bring up a couple of papers. Let me bring up 2026. I will just all right, so question here. 2026. So we can bring up a second one. It's transformation. All right, this page is a page of functions. All of these questions. You answer them. Take a couple minutes and run them through. Let me bring up another paper beside. Let me split the screen and bring up another paper beside. 2020. Twenty 2026. 2025. There might be some repeats. See them there. You guys can see them, right? Do them for me a minute. Let me just do this thing for work quickly. All right, give me a minute. Do those questions some quick. Do the questions. question. Close. Close. Closer. We can't see that. But we can't see that. Because we can't focus. So I said, about to sit down, come here and look at what I said. I can't see you can't see the bigger and young. I don't know if I can see, you can see. Guys, the youngsters. So I said, yeah, I'm finished, yeah? All right, cool. All right, guys, ready? Ready, ready, ready. Let's do these couple questions. Huh? Come on. Come on. Huh? I'm going to do all of them. This is not enough time for though. I same question and repeats. Which are these a straight line? This one. Point where the line crosses the horizontal axis is the x-axis intercept. Again, same question. Which is the mapping diagram? Many to one, many to one, many to one, many to one. This one. What's the gradient of this time? We need to get rid of this 2. So you have to write this line as y equals minus 3 over 2x minus 4. So the gradient is minus 3 over 2 right here. This one, the one h of 4. Put 4 right there, so you get 3 times 4 minus 2 over 5. That's 10 over 5, which is 2. You know, then I want f to the minus 1 of negative 1. F to the minus 1 of 1. Everybody should know this. This just equal 1, guys. F of f to the minus 1 of any number, I give about the same number. I like your map, do a mapping and reverse the same mapping. So the answer is gonna just come back to 1. Reverse, I go that way as well. F to the minus 1 of f of any number equal the same number. The inverse, the function of the inverse basically net out anything. Like a drag go forward and drag come back. All right? But the function are reverse of each other. All right, that finished that right there. So. This one, after the maximum point, the same point up here again. Same question we did this one already. Point up here is a 2, 4. According to the graph, solution between this and y equals 0. Remember, y equals 0 is the x-axis. Y equals 0 is the x-axis. We're talking about these 2 points. On the x-axis, y equals 0. So that's 0 and 4. 0 and 4. 0 and 4. 0 and 0 is the answer. All right. Next one. So this is the same question after. We're going to try to change it up a little bit. 0 and 4 are the two x values. 0, 0 is the y value. On the x-axis, the y value is always 0 on the x-axis. This one, h to the minus half. H of minus half in here becomes 4 times minus half squared. Assuming that's a square minus 6. Assume that this is a square. So minus half square becomes a quarter. So it becomes 4 times a quarter minus 6. That becomes 1 minus 6, which is negative 5. Negative 5. All right. Go to the cube. When we go to the cube, it will be 4 times minus a half cube. Let's see if this will work. No. Minus 6. That answer will be there for it. This should be minus 4 over 8, which is minus a half. Oh, no, the answers will work. So could be that has to be a square. Thing is, this one out where the perpendicular lines, where perpendicular lines is negative 1. So it's got to be the perpendicular lines negative 1. So if we get this line, the grade is going to be 2. If I take this one and bring it over here, you're going to get y equals 2x minus 8. So the grade is 2. So the perpendicular grade of 2 is minus a half. But understand that. Keep it and change the sign. Minus a half is the perpendicular grade. But the grade of this line is 2. All right, next one. Same question we did earlier. So the following function is this. I plug in these values in here. Plug that value there first, get the 0, 3. Then plug the 1, you're going to get 4. With this already, right? Plug the 2, we did this one already. 52. All right, that's that. Let's look at 2024. Let's look at 2024. 2024, January 2024. Right here. After this, we take a short break. And then we'll come back and start. 2024. What solution is that lower solution? The lower solution that 2024 result. Uh, 2024. Let's see if there's anything else on this that I'm not yet done after the statistics. Here. What is the y-intercept of this line? Y-intercept going to be negative 4. Because remember, you have to divide by the 2. Get it in the form y equals, get it in the form y equals minus 3 over 2x minus 4. Y-intercept is negative 4. Do this one already. This will probably 4 and this will do that one already. This is the one, if the minus one of 1, do that one already as well. Right? Like I said, f of x equals 5x minus 2x. But this equation that you're trying to solve is that f of minus 1 equals some number. So 1 equals f of that number. So you can try which one of these values you plug in this. You're going to get the 1. You're going to get the 1. It's going to be the 2. We put the 2 and plug it in here. We're going to get 5 minus 4, which is 1. So it's a 2 is the answer. This is the answer. All right. So we did that one already as well. Then we did this as well. Values of x at which point intersect the x-axis. You put this equals 0. So on the x-axis, y equals 0. So you put this equals 0. So you get 4x minus x squared equals 0. Factorize the x, going to get 4 minus x equals 0. So that this equal is 0, and that this equal is 0, which is x equals 0, or 4 minus x equals 0. 4 minus x equals 0. Go over the x, then the x equals 4. So 0 and 4 are the two x values right here, 0 and 4. All right, with that, and that finishes that one. This one says, which line perpendicular? We do this one already, please. Minus 5 over 2, right? This one, minus 5 over 2. Perpendicular gradient, negative reciprocal. And let's look at June now. Let me take a view. June. June 2020. June 2025 and 2024. We've seen a different question. June 2025 and 2024, if we send a different question. So see same question come back here, which one's the linear function? This one. So see it's come on a lot of paper. I don't know people stopping and guessing on that one. And come on almost every paper. That makes sense, guys. Here the marks for the maximum point again, which is right up here, so 2, 4. Make sure it's 2, 4 now. They change it. Make sure. Then I give this function. That's what I say for this one. Now this one look different. Which of the following function is undefined at the point x equal minus 2? Remember, it's undefined when the denominator is 0, right? Undefined when the denominator is 0. So put this denominator equals 0, you're going to get 2 minus x equals 0. You're going to get x equals 2. That's not the one that they want. You're going to get x equals 2. That's not the one that they want. Huh? So it is the last one. So that the last one. Last one, you're going to have x plus 2 equals 0. So you're going to have x equals negative 2. So this last one is undefined when it's x equals negative 2. So the x value to make the denominator equal 0. And it's on the last one. All right, undefined. All right, that one look different. G of minus 1. If I put g of 1 minus 1 first and then g of again, right? So this is g of, when the g of minus 1, we're going to put the minus 1 in this. So that become minus 1 squared plus 1. Minus 1 squared is a 1. 1 and 1 is 2. So you're doing g of 2 now. Then g of 2 now, we're going to put 2 in this now. So it's going to become 2 squared plus 1. So that size 5. This one, I don't recall seeing this one before. All right, but it's not difficult. We do this one already. Parking lot for $1. $1 is a fixed cost, 25 cents per hour. That's exact one. That one already. This one up here, that's a relationship. Over here says 3 more than over here. So the y value is x plus 3. Do that one as well. All right, that done. 2024 June. June 2024. June 2024. Let's see. June 2024. Here we go. Which of them is a function? Same question. It is this one, right? This one right here. The function. See it? Same question we did earlier. Which of them is a crosses the horizontal axis? So they set this question already and I asked about the vertical axis. You know? They're asking for the horizontal axis on this one now. So I thought this one is now talking about this point, 3, 0. 3, 0 now. So another question to be 0, -2. That's why I have to read the question. You can't just see the diagram and just think it's the same question. You know? Read the question. I will set the same diagram and answer a whole bunch of different things. All right? That CSEC tend to do that. Because of a straight line as well. Because of a straight line. Oh, because of this straight line up here. What's the gradient? If we check the rise is 2 and the run is 3, don't it? So the rise is 2, the gradient is rise 2, run 3. And the y-axis intercept is -2, don't it? Equal -2. So that one is this one. Rise 2, run 3. All right? See it? Rise 2, run 3 to go from here to here. That is it. So the gradient is 2 or 3. All right? So that is that. Here again, I ask for the maximum point, which is again up here, 2, 4. Keep setting this same question. Equation of axis of symmetry again in the line x equals 2, x equals the x for that turning point. This vertical line down here is the axis of symmetry, x equals 2. And that's the maximum point. And then here now the one, g to minus 1 of -2, the one. So I would say something like this. G to minus 1 of -2, I'm going to put -2 equals g of some number. And any one of them number here now, we're plugging at this, we equal -2 is the answer. See that? G of some number is -2. So I can test them or I can solve it by putting this as that function. So you have -2 equals 7n minus 3 over 5. When you find n, you find the answer. 1 the 2 over here, 5 over here, so first I get minus 10 equals 7n minus 3. Here over the 3, add it, I get -7 equals 7n. If I by this 7, I get -1. So the n equals -1. So the answer is -1. That is it. See that? Good? All right. And then this one is the parking lot question again. Really careful, make sure the same question. So the fixed charge is $1 and then 25 cents per hour, right? So this is it. That is it. I think we're done. 52. Range of function. Oh, so range of function on this one again. The last one, right? We did this question earlier. Same exact question. That is it. All right. So let's take a short break. Put 15 minutes up on the thing. Take a short break and then we'll come back. And I will go into the measurements. See, look at that measurement, the tricks, the rest of the questions. Let's see, we really reach 50 some. So we're looking at the rest of the questions to finish the paper. We're like 50, 52 right now. So we're finish the questions them on the paper, right? But we're gonna do about the bank first. Then after we finish the bank, come back on this paper, the last set, and then we'll try to see if we can get in the vectors before we finish. Because we did not do vectors. Try to see if we can get in some vectors. All right. I'll put up the clock. Hold on, there's a question on the January. And I'll put up the clock. Let me put up the clock. Hold on. Oh, what's up? Hmm? Oh, okay. Huh? What's the progress of the thing? What the thing? What's up? You get what? So, so the glass drop out. The glass drop out.
Sir, you're muted.
Sorry about that. Sorry about that. Let's go again. Right. Sorry about that, guys. So let's do this again. Let's do this again. Right. So I'm saying how the translation works, that you have the point, and the point is moved by these amounts. This is the X amount that it is moved. That's the Y amount that it is moved. So you have the point 3, -5. You apply a translation to it of 2, -3. This X value is going to increase by 2 to 5. And this X value is going to decrease by 3. But the -3 means that they're decreasing it by 3. So -5 subtract 3 become -8. And that is why this is the answer right here. This is the same kind of question. So this X value is going to be adjusted by -2. So it's going to go to -7. This is the only answer with a -7 X value. So this is the answer right here again. You can see it. -5, 3. Under the translation of -2, 3. It's going to go to -5 and -2 makes -7. And 3 and 3 makes 6. This is actually a 3 right here. So that's the answer right here. Next one. At this point, again, under the same translation, I'm going to move this by 3. So you have -2 plus 3 becomes 1. The only value with a 1 at the X value is this one. So again, -2, 3. Under the translation of 3, 4. -2 plus the 3 going to become 1. 3 and the 4 is going to become 7. So 1, 7 is the answer for that one. So all these questions basically the same, right? With different values. Another one here again. This one is asking for the translation. So it says the image of this point under translation is this. So you can set up this way. So it's like you have the point 1, 2, and carry to a translation. Let's call it translation AB. And it goes to the point -5, -4. So what happens is that this one has been reduced to -1. I can say 1 and A, 1 plus A equal this -5. So I find the A care about the negative, care about the one to make it negative. So the A equal -6. So this is the only answer that A equal -6. So that has to be the answer right there. This one. Something like that. All right. Or from 1 to go down to -5, you have to subtract 6. Anyway you want to look at it. This question says, if you follow the diagram below, what transformation maps PQR onto P prime, Q prime, R prime? Now, that's a reflection. To confirm it's a reflection, you can check the orientation. So P to Q to R, and this one is clockwise. But P to Q, let's go again. Oh, I did it the wrong way. P to Q to R is the other way. My mistake. P to Q to R is this way, anti-clockwise. P to Q to R, and this one is the opposite way, clockwise. Orientation is reverse. So you know I have a reflection in a line. So the transformation is a reflection, but the orientation is reversed. When you're reflecting a line, the orientation is reversed. All right. So when P to Q to R, that's this way. And P to Q to R is this way. So one is clockwise, the other one is anti-clockwise. Same thing happening over here. P to Q to R, and this one is this way. That's anti-clockwise. P to Q to R, and this one is this way. That's clockwise. Orientation again is reverse. Same answer, we have a reflection. Two different exam papers, I set them like that. All right, down here. This again says line CD is the image of AB. So under what? CD is the image of AB. Looks like a reflection in this line. Looks like a reflection in this line. I want to know because these are the same distance, same distance. And this one is same distance over here. Same distance. A reflection in this line. So it's a reflection in the y-axis. So here, a reflection in the y-axis. Which is obvious. This one over here. It says that straight line is y equals x. What is the image of y equals x when it's rotated anticlockwise about the origin through 90 degrees? So that you have this line, and I'm gonna rotate it. 90 degrees. So it's gonna go like this. Well, it's not working out, but anyway. So you have this line. And you want to rotate it 90 degrees this way, anti-clockwise, it's gonna come to here. If you rotate this line anti-clockwise 90 degrees this way, about the origin, such as this angle right here is 90 degrees. That clearly is the line y equals minus x. This is the line y equals negative x. The blue line is the line y equals negative x. That's what we're gonna get. Y equals negative x right here. If we rotate y equals x. Here they're asking a similar question. It says, what is the image of y equals negative x when it is rotated again anti-clockwise about the origin through 90 degrees? You're getting back y equals x. If we take this now, you rotate it down there again, it's coming to there, 90 degrees. So you're going to end up getting this line. If you rotate this 90 degrees this way, about origin, 90 degrees, you get about the line y equals x. That's it. You get about the line y equals x. So you see, same question, adjust it a bit, and I put an exam paper. All right, so that's that. Here the popular question that I ask all the time. So this one a lot on past papers. They say this line is mapped onto that line. And they're asking us what transformation it is. But the tell is a translation, and they're asking us for the translation vector that maps A, B onto A prime, B prime. So it's to count how many is to the right, how many is upwards or downwards. So this point goes up to there, right? So horizontally, it goes from 2 over to 7 as a plus 2. And then go up from 7 to 8 as a plus 1. So the translation is 2 to the right, 1 up. 2, 1. 2 to the right, 1 up. If it's from this line to this line and change it, it's going to be 2 to the left and 1 down. So it'll be negative 2, negative 1. It'll change it, the direction. All right, that reverse the mapping. So it's 2, 1. We're looking for right here, 2, 1. Nice and easy. This one, it says in the diagram, the translation which maps A, B, C, and to A prime, B prime, C prime is what? So this is what happened to 1 point. For example, C to C prime. That's all. On the units, how much it moves horizontally and how much vertically. So horizontally move to the left. So that's a negative movement horizontally. 1, 2, 3, 4, 5. 5 to the left, that's a negative 5. 5 to the left is negative 5. And then it goes 1, 2, 3 upwards. That's a positive 3. So the translation is negative 5, 3. Negative 5, 3. Cannot do it, but I think this is the negative 5, 3. This is the negative 5, 3. I think that's what I said. This is 5, 3. That's even sure. So -5, -3. And this is 5, 3. So this must be one of these two, and I'm not sure. But the answer is -5, 3. Whichever answer is -5, 3 is the answer. Let's put that's 5, -3. So if that is the case, this will be the answer. -5, 3. Alright. Use those are that. But go to that. Score the units horizontally. You want to go to the left, negative. If it went down, vertical component with negative as well. This one. This one give us this is mapped onto that one. And they tell us it's an enlargement. And it asks us for the scale factor. Very easy. Just need to compare one side. So this side was 1 unit. It has grown to 2 units. That's a multiplier of 2. And so the scale factor is therefore 2. It's a positive scale factor. Because the image of the object point in the same direction. So for example, CA pointing up on the object, CA is still pointing up on the image. So that makes it a positive scale factor. So scale factor is positive 2 right here. All right, positive scale factor. Because the image of the object pointing in the same direction. Another thing is that both of them are on the right side of the center. Both of them are on the same side of the center. That's another way you know the scale factor is negative, positive. When scale factor is negative, the center is between them. The scale factor is negative, the center is between the image and the object of enlargement. Here's another popular question right here. It says the length of MO, because these are a pair of similar triangles. Similar triangle, the ratio of corresponding sides equal. So this side to this side is a multiplier of a half. Then from this to this, which are the corresponding sides, if I apply the same half, you're going to half this. If I half 7, you're going to get 3.5. 3.5. So this side is going to become 3.5. The MO is going to be 3.5. MO is 3.5, half of 7. But the ratio of corresponding sides are equal. It looks like an enlargement wheel, similar to enlargement. All right. Next one, same question we have here. So we have similar triangles again. Area now, this one is about area. So remember, when it comes to area now, the ratio of the area is the ratio of the square of corresponding sides. So see you know, the area of the big one. That's the area of the big one. Let's call that area big. Over the area of the small one, area small, is equal to a big side squared, which is 6 squared, over the corresponding small side squared, which is 3 squared. So we have to remember, the ratio of the area is the ratio of the square of corresponding side. What is question saying? It says if the area of the big triangle is 20, this can do another way. Let's do it 2 ways. That'll give us some dimensions to actually find some sides. So this is one way to do it. And they're asking us for the area of the small one. So we can tell reciprocal of this and flip it. Let's flip it. So instead of doing it that way, we can flip this side and say the area of the small one over the area of the big one equal a small side squared over corresponding big side squared. So we can do it that way instead. Since it's here the small one we want, we put what we're trying to find on top of the fraction, easier to transpose. And they tell us that the area of the big one is actually 20, right? So we can put 20 on here, so and multiply it up there. So the area of the small one becomes 9 over 36. That becomes 9, 3 squared is 9, 6 squared is 36 times the 20. Right? The 9 over 36 is 1 over 4. 9 to that goes 1 time, 9 to 36 goes 4 times. 20 divided by 4 is 5. So the area of the small one is 5. So the answer here is 5 right here. But another way we could do it, since they tell us the area of the big one, we could work out what the height is. And then use about the same height over here, half it, and then calculate the small one that way. So we find the big, call this big H, and work it out and call this small h. Small h is half of the big H because it's the same scale factor. Right? Same similar triangle, same factor they reduce by. So we could say since the area is 20, we could say half 6 times big H is equal to 20. So therefore big H is equal to 20 over 3, because it's a half of 6 is 3. So big H is 20 over 3. So big H is 20 over 3, then small h is half of the big H. Half of the big H. Which means that the small h is half of 20 over 3, which therefore is 10 over 3. So therefore the area, yes or no, of the small one is half of 3 times this, half base times height. So you have the small one, will be half the base is 3, times the height, which is h, and the h is 10 over 3. 10 over 3. So you see you get 5 same way. 3 cancels 3, and then half of the 10 there, so it's 5. So I could have been done that this way as well. This is 5. So 2 ways it could be done. Alright. We'll come to this diagram here. So refer to the diagram which shows the rectangle WXYZ and its image W prime, X prime, Y prime, Z prime, and double prime, double prime 1. After it undergoes a composite double transformation. So that's what this one. So this gotta go from this one to this one first, and then from that one to this one. See now, pay attention. Now I learn nothing. Can't tell people act like they serious and they're not really serious. Eh? You act like you're serious, but you're not serious. Alright? Alright. So from this to this look like a reflection to me. Oh, I know, because this distance from here to here, the same thing to Z prime. And then this one now, the distance is halfway from this line. That looks like a reflection in the y-axis first transformation. Then from this to this is clearly an enlargement. From this to this is an enlargement, guys. But scale factor is a half. One was a half. But this side was 2 units, and it's gone down to 1 unit. So scale factor is a half. Hey, yes, I'm going to end the class on Sunday. No, pay attention. You know, one set of jokers, you know. That one set of jokers, I tell you. And then to find the center of the enlargement, guys, you join the corresponding points like this to this. And look like it's the origin here. And you can join maybe y and y prime, y and y double prime. Extend it down here. They meet at the center, right? So the center of that enlargement is the origin, and the scale factor of the enlargement is a half. So that's a reflection in the y-axis, and then an enlargement of scale factor half about the origin. All right, so we have established that. Let's see what the questions are. It says, sequence of transformation which maps this one to this one. We know the reflection in the y-axis first. Let's look for that. Translation that wrong. A reflection in the y-axis, followed by an enlargement, center origin, scale factor half. That is it. This is it. That is the one that we just described a while ago here. Reflection of the y-axis and then an enlargement of scale factor half about the origin. Done. All right. This one here. It said the type of remember I told you guys about the positive and the negative rotation. Remember I keep telling you clockwise rotation is actually negative. Anti-clockwise rotation is positive. You can't remember, just remember the x and y axis. Yes, so yes, the positive quadrant. So if you're gonna move the x-axis up into the positive quadrant, in other words, to move the x-axis to the positive quadrant, you have to go anti-clockwise. That's why anti-clockwise rotation is positive rotation, clockwise rotation is negative rotation. See that? I see a question here that give you that, and give you the negative and the positive. So you have to know that 1 year is clockwise and 1 year is anti-clockwise. That's what you have to know. The negative 90 means clockwise, -90 degrees, and the positive 90, that's what the negative 90 means. Negative 90 means clockwise 90. Negative 90 degrees means clockwise 90 degrees. This positive 90 degrees, at positive 90 degrees, means anti-clockwise. Hey, if I want to know, I'm telling you everything, you know, teaching you everything. That's all I'm talking I'm telling you about. And it's say, whole question will go through, and I know one question in common. Also, I'm telling you multiple times. But the clockwise and anti-clockwise. No, no, busy, I get them somewhere wrong in the exam. But drilling upon them things there. But then I'm not really serious about retaining information. You guys don't do things to retain information. I'm telling you, say it's special because you hardly see it. Most question will go through, one question alone in common. Come on your paper, you want to make sure you get it. Make other people get it wrong. Right? So, which transformation is this? It is from this one to this one. So, oh, you can know, look at it. This line that was horizontal, O to Q, has gone vertical. So, the rotation has been up this way. See? And it's true 90 degrees, because the angle between here and here is 90 degrees. So, that's clearly an anti-clockwise 90-degree rotation about the origin. Right? If you look at this one, this line that was here has now gone to there. Again, you're rotating it this way about the origin. So it's again anti-clockwise. Anti-clockwise rotation is positive rotation. So the positive one, this one is the positive one. Clockwise rotation is negative. So the answer is the positive one, the positive rotation. See, them two are clearly out of it, you know. Right? So it's one of these two, but how are you gonna know which one it is? You have to know what positive rotation is and what negative rotation is. Right? You have to know. So see, the answer is this one, the anti-clockwise one. But anti-clockwise rotation is positive rotation. Right? Anti-clockwise rotation is positive rotation. I think that's basically almost it. Put it on the last. No, not done yet. Let's go. This one says, in each of the diagrams, A prime is the image of A. Which of diagram shows a reflection in the x-axis? A reflection in the x-axis. Can be this, because this reflect to the x-axis and coming on to here. So it can be that. Same thing here. This reflecting x-axis coming on to here. Can be that. This reflecting x-axis coming on to here. Can be that. This is, must be it then. This reflecting the x-axis coming out here. So it must be this one. I just now can't teach this because it's just straight obvious and straightforward. Same question I set a different way. See? Say each of the following diagram, O is the image of OA prime is the image of OA. Which of the diagram is a reflection of the y-axis? So they change it, y-axis. Up here they said x-axis. Same question. Set by the same question I say y-axis now. So if you go swap the answer there, you might pick the wrong one. Reflecting the y-axis. So reflecting the y-axis, this is supposed to come over here, so which it didn't. This come over here, so which it does. So that's what we're supposed to have. This looks like it. That is it. Look at that, it's supposed to come away, so it didn't. That's wrong. It's supposed to come across here, so again, which is wrong. So clearly you have selected the right answer right here. All right. Now come to some trigonometry now. So much good job, right? Still have a good amount of work left. All right, some tricks. This is circle theory. Angular center is twice angular circumference, don't it? So this is 100, right? 100. Angular center is twice the angular circumference. This one. So this one says, what's the size of angle alpha? Now remember now, these two sides are the same, so that's isosceles. So if this angle is alpha, then this angle is alpha too, don't it? And the diameter subtends 90 degrees. So right this are 90 degrees. So these two add up must add up to 90 degrees, don't it? So 2 times alpha equals 90 degrees. So alpha equals 45 degrees, don't it? So alpha is 45 degrees. All right, that's an easy. Next one. What's the relation between these lines? Z angles. Come along here, come down here, go down there. These two angles are alternate angles, they're equal, right? Alternate angles are equal. Right here. That's it. Next one, same thing. Alternate angles again. Them say P and Q this time. Again, them equal, right? X and Y, P and Q, same thing. Them equal. Alternate angles are equal. Suppose them do this. Suppose them do this. Suppose them do it for an exam paper. Suppose them take this from here, so. And put the Q over here so instead. What's the relationship between them now? Huh? They add up to 180. Co-interior angles. They become co-interior angles. So this line, that line parallel, you are joined by this. Like you have angles in the U angles. So in that case, the P plus Q will be 180 degrees. Similarly, them two are up to 182. In that case, you're looking at a U this way. This way. So the U will be like this now. So these two angles, this is X, this is Y, X plus Y, we 180 degrees as well. All right, so just giving you that, because they could make that simple change on this question and answer those things. The number one here, P plus Q equals 180. That tells me that I can put the Q over here, so I put the P over here, so and ask you that same question, and then this will be the answer. As I just showed you already. See it? Right. The answer is Asha never show you. Next question. That's an isosceles triangle. Means that this angle don't start 30, don't it? Then to up to 60. So the rest of it take you up to 180 must be over 120, don't it? So 120. Put along with 180. Next one. One angle is X and one angle is 2X. What is the third angle? 180 minus some of these two. No, so 180 minus 3X. For that, 180 minus 3X. Easy. Same thing here, so. One angle is X, one angle is X. What is the angle C? Same question. 180 minus 3X. Same question. All right, once a P and Q, down here, so them say A, B, and C. It's same question really. All right, over here, same thing again. One angle is TX. And that's what this one says, that they're trying to change something. It says if angle P is formed by two equal, let's say, if angle P formed by two equal sides of an isosceles triangle, PQR, let's look at it now. And P is X, so this is angle P. I'll draw that this way. Painting I'm not sure, you can just make a sketch. So this is P and angle P. Angle P is formed by two equal sides. These two equal sides form angle P, and angle P is equal to X up here. So that's what they basically say. What is the side of angle Q or R? So this is P, Q, R. They're asking us for these two angles now. Let's call them theta. What do you mean call theta, don't it? Right, so they're asking for those two angles now. So because them equal, you go under 180 minus the x and then divide by 2, don't it? Don't it? So the theta is going to be 180 degrees minus the x divided by 2, which therefore is this answer right here. Typical isosceles triangle question. Down here, I say in a polygon, angle A is x, and angle A and angle B are supplementary. Supplementary mean. Supplementary mean. I don't know what supplementary mean. I would have used 1,000,000 times through the and I don't know supplementary. Which class in this ago? I can't my class. Supplementary means that they add up to 180 degrees. Complementary means that they add up to 90 degrees. Come on, man, I could do better than this exam on Thursday. Which class in this ago? From September. Oh, Jesus. Right? So what is the size of angle B? This one, that add up to 180. See that? Them supplementary, they add up to 180. So one is 180 minus the next one. Oh boy. Supplementary sounds strange there. I would use so much time on a circle theory, we use supplementary so much time. Opposite angles of a cyclic quadrilateral are supplementary. Must I use a word there? Opposite angles of a cyclic quadrilateral are supplementary. Add up to 180. Every time I write supplementary, I write meaning that they add to 180 degrees. You don't understand what the kids nowadays, you know? I don't understand it. But it look blank, I didn't want to see where supplementary before. Anyway, I have to just do my job, you know. I know do my job well. Very, very well. Right? You don't take the learnings and the teachings and apply, can't help them. We know me do me for do, but expose them to everything over and over again. So we don't want to sit down blank on the word supplementary. Or we use so much time with circle theory. Anyway, angle of depression is x from z to x, right? Angle of depression is this 30 degrees here. It's 30 degrees here, 35 degrees here. So remember the angle of depression from the top up here equal angle of elevation from the bottom down here. So you're basically forming Z angles. So if out here so is 35 degrees, then in here so is 35 degrees as well. Normally write it inside the triangle. You want it inside the triangle to help you. This angle is 35 degrees as well. So you can work in this right angle triangle. Question says, what is the height YV over here, so? So that's the opposite side we want. And we know they're adjacent. Opposite and adjacent connected with tangent ratio. So tan of 35 degrees equal the opposite side that you're trying to find over the adjacent side of 12. Take the 12 and multiply it up here, you get the opposite side that you want. So the opposite side becomes 12 times the tan of 35 degrees, which is right here. That is it. Opposite side is the YZ that I want. That triangle. Same question down here, so. This time now I want the XY, see? I want something different with the XY. They tell you now the height is 12. So they're trying to make changes on the question. But the first thing is the same. Z angle is equal. Angle of depression from the top equals angle of elevation from the bottom. So inside it says 35 degrees. The sort of a question now that you're trying to find the adjacent. The adjacent is what you're trying to find now, this side. The adjacent side. Right? XY is the adjacent side, and you know the opposite. This is not the opposite. So you now know the opposite. But the same tan, same thing. Tan of 35 degrees equal the opposite side of 12 over the adjacent side that you're trying to find. We find the adjacent side. Multiply it up here, so take the tan 35 and divide it under there. Simple. I've done this 1 million times before. So the adjacent side that you want becomes 12 divided by the tan of 35 degrees. All right, so don't go swatting. All right, so you have made a change. 12 over tan of 35. Huh? Yeah, I'm going to find out other angle person. The 55 is the answer. But this answer not there. So it means that they are using this angle up here. Let's put on in red. So it's clearly using this angle, which is 55 degrees. In that case now, the tan of 55 degrees equals the opposite side, which is the adjacent, over the opposite over, sorry. To that red angle, look, to that red angle, that's not on the adjacent. This is not the opposite. So to the red angle, this is not the opposite. And this is not the adjacent. Understand that? To the red angle. So the tan of 55 equal the opposite we want now from the red angle. We want the opposite now from the red angle, which is the XY, over the adjacent, which is 12. So you take the 12 and multiply it up here now. And you're gonna get that the opposite side that you want becomes 12 times the tan of 55 degrees. That's why that is not a possible answer that they gave us right here. But this one is missing, so don't get panic. Don't panic. Don't say carry from that angle up here. If you don't find that one, don't panic. All right, that is it. That worked from the 55. I can see the 55 in the answer. So that is it. All right, that is it. Only the same question again, but I put 10 now. And I wanted to find this side. So same calculation. Okay, so it's 30. So inside here, so it's 30 as well. That is the key. Asking you for the opposite side. And you know the adjacent side. So same calculation. Tan of 30 degrees equals the opposite side that you want over the adjacent side of 10. So the 10 I multiplied up here, that opposite side that you want becomes equal to 10 times the tan of 30 degrees. 10 times the tan of 30 degrees is the side that you want. That is it right there. You see, all these questions are the same with minor little changes. This question says a lot. It says, which trig ratio is equal to 4 over 8? 4 over 8. So, there are two possibilities. You can be working from the y. If you're working from the y, this is always the hypotenuse. And this becomes the adjacent if you're working from the y. All right? But if you're working from the x, this is not the opposite if you're working from the x. And this is adjacent. Let me set up this way. Let me set up this way. So this is the hypotenuse regardless, right? So this is the adjacent to x. This is the adjacent to x, but opposite to y. One. And this side is the adjacent to y, but opposite to x. So depending on which angle you're using, it can be opposite or adjacent. Each of those two sides. All right, let's work it. So if we're working the side, the x, then this becomes the opposite of our hypotenuse. So that is sine, right? So it means that the sine of x is the opposite, which is 4, over the hypotenuse, which is 8. If we're working from the y, then the cos of y is the adjacent to y, the adjacent, which is a 4, over the hypotenuse, which is 8. So that the sine of x or the cos of y is the answer. See that? Sine of x or the cos of y is the answer for that. Which one is there? Sine of x is there. That is it. All right. We have this triangle down here. And this is the hypotenuse of 40, that angle is 30 degrees. What I want us to find? I want us to find BC. BC is the opposite side, don't it? That's the hypotenuse here. Opposite than hypotenuse is sine trig. So I want to say the sine of 30 degrees equal the opposite that we want over the hypotenuse of 40. Take the 40 and multiply it up here. The opposite side that we want becomes equal to 40 times the sine of 30 degrees. 40 sine 30, this one. All right, because it's BC, we want the opposite to the angle 30 degrees. Up here now. This can give us this diagram. This angle here says 58 degrees, this line's cross. We said the angle of 58, don't it? Call them vertical opposite angles, right? And then now, and then this angle and this angle up to 180, right? So right here, so becomes 180 degrees minus 58, right? As a total angle, not straight line. All right, and then now when you get this angle here is the same as it, right? All right, that's what I want us to do. The measure of angle ABE. ABE. That's this angle that I want right here. That's 180 minus 58, don't it? That angle is equal to 180 degrees minus 58 degrees, which is what, 42. 42 degrees. 142 degrees. 142 degrees. All right, total angle of straight line is 180. Next angle. So which of the following angles are equal? Let's look which of the following angles are equal. The vertical opposite angles are equal, right? Vertical opposite angles. Huh? Huh? 122 or mistake, man. 122. Thanks. 122. 122. Yeah, 122. Thanks. All right. So what is the which are the following angles are equal? Let's look at the vertical opposite angles are equal. So EBC and CBE. Let's look at them. Let me take this out. So let me say DBC, that's up here, so, and CBE, right here, so that's wrong. They're not equal, right? So the first one wrong. Next one, CBE, and ABE. As I understand this, no, they're not equal. Looking for the vertical opposite angles. Next one, ABD, which is the 58, and CBD, C to B to D. That's this one. No, they're not equal. So that must be the last one then. ABD, which is inside here, and CBE inside here. Those two angles are vertical opposite. They are equal. And that is it. Right? Nice and easy. All right. I'm going to come to the, no, we're still not done yet. This one says, plane flying in the direction of 045 degrees changes course in a clockwise direction to 135 degrees. The angle through which it turns is what? So it's like you're going this way. So you're not line here, so. And it is going at 45 degrees. So you're going so at 045 degrees, right? Then when you reach right here, so it's still an outline again. It is now going on a bearing of 135 degrees. So you're going down so now. We know this angle is 135 degrees. So what angle did it turn through? It was going this way. That's where it was going, you know. and it turned and is now going this way. So the direction has turned through 90 degrees. You see that? What is that? That is it. It has turned through 90 degrees. That is it. All right. It was the original direction, and now this is it is direction, so it has turned through 90 degrees. We go from a bearing of 040 to 135. Maybe we could also subtract it. But anyway, that is that. Anything else? Yeah, well, this last page down here. This one says a ship sailed 8 kilometers due east from A to B, and then sailed 6 kilometers due north. All right, which are these diagrams represent information? All right. So it says 8 kilometers due east. Due east means towards the east. So go 8 kilometers south first. From A to B. All right. And then it goes 6 kilometers due north. That's towards the north. 6 kilometers to C. So that's the diagram we're looking for, right? 8 across and 6 up. 8 across, 8 to the right, 6 up. 8 sit here, 8 to the right, 6 up. That's it. That's the answer right there. Based on what I've said. This question, they like to set this question a lot as well. And see the asking the same thing. So a surveyor sets up his instrument 12 meters on the foot of a building and record the angle of elevation top of the building. An estimate of the height of the building is obtained by calculating what? So what it is that its length is 12. This length is also 12. Its height is 1.6. So this height of the building part up to here is also 1.6 meters. And to get overall height of the building, we would need this additional height up here. Let's call that H. And so we're working in this triangle. Working in this triangle up here so now. And in that triangle, the right angle triangle, we could say tan of 40 equal opposite over adjacent. So we could say tan 40 degrees equal the opposite of 8 over the adjacent of 12. Then the 12 are multiplied up here. That H in the diagram becomes 12 tan of 40. But that's not the total height of the building. Total height of the building is the H plus the 1.6. So if I add them, so it's the H plus the 1.6 and 1.6 plus H. This one. This one becomes 1.6 plus H. So this is the answer right here. Very good. And that finishes that. Time is it now? We have half an hour left. Remember run some vectors on this document. I want to do no vectors, right? Let's run some vectors on this document. Maybe tomorrow you can touch some 3 papers there again. 2020. I'll let you do the 3 papers tomorrow. 20, no, the 5 papers. You can print them out. I'll come with them tomorrow. That'll be good. You can print them out. I'm not going to print them because I'm not printing so many pages. And plus, I don't know how many people come in at the next day. As I print a lot of documents one day come in and people not turn up. I've been asked, show of hands who will come in. People, a lot of people took them on in the group. And I printed the document based on the number, based on the hands that went up in the group. All some people never come. I waste some money print the paper them. Print your own papers. I'm not printing any. We bring a device. I'm not printing any. You know what, Mike, I pull up how much paper I'm waste already. No, I'm not printing any. I'm not printing not even one. Not printing any. Print your own paper. Not printing any. Hey, I'm saying don't talk. I'm not print none. Much people I'm waste in our class. I print too much something. People not come for them. Yeah, but I asked a specific question to go. Who come into the thing? A lot of hands went up. I come in. I'm a print based on the hands that went up, and then no, you end up having double the paper then. Happy we don't put. Dump them, we must do them. Anyway, let's go. We're going to finish all these vectors. This question says P and Q are those two vectors. And I want minus P and minus 2P. You have to be careful. They set this thing all the time and they keep changing this combination of the P and the Q. All right. So if you want minus P, you want minus this. So like you want minus 3, 2, minus 2 times this one, minus 1, 4. So you have to be careful with those negatives. This one first becomes negative 3, negative 2. Then the minus 2 times this becomes, I can put minus and transpose in the one alone. So put minus transpose in the one. The 2, sorry. 2 times minus 1 is negative 2. 2 times 4 is 8. So you leave this minus out there. If you use the minus 2, you're going to change it to a plus. They're subtracting these now. Minus 3 and minus a negative 2 becomes minus 3 plus 2. This is the only value with a negative 1 in it as the first value. And then minus 2 minus 8. There, minus 2 minus 8. So that becomes that vector right there. So with this one, let's have a careful with the negatives. Right? It's pretty straightforward. So another one here. Now them just want P minus Q. Right? So this minus this. Minus minus becomes a plus. It's 3 minus a negative 2. 7 minus 5. That's what you're doing. This becomes a 5 up here. So it's 5, 2 the answer. 5, 2 is right here. So it asks the same vector, but it asks something different. P minus 2Q. Here's P minus Q, now it's P minus 2Q. So keep changing what the setting guy, but careful. So the P is 3, 7 minus 2 times this. 2 times the Q. 2 times the negative 2 is negative 4. 2 times the 5 is 10. So you're subtracting negative 4, 10. So minus minus becomes a plus. So it becomes 3 plus 4 is 7. 7 minus 10 is negative 3. So you're going for 7, negative 3. That's not there. No. 7. Oh, you see it here. So 7, negative 3. All right. Up here, so now. Same thing again. See? Those two and one, P minus 2Q again. So the P is 3, 2 minus 2 times this. So you're subtracting minus 2, 8. 2 times this. So again, the minus minus becomes a plus. It becomes 3 plus 2. 2 minus 8. 2 minus 8. That works out to be 5, negative 6. 5, negative 6 right here. So these questions are pretty straightforward, guys. Just have to be careful with the signs. Got this one now. They give us this parallelogram. So, you know, in a parallelogram, the opposite sides are equal vectors, all right? So the vector here and the vector here is the same. The vector here and the vector here is the same. That's what they said. They said, based on the information above, ZR is equal to what? ZR. And I want to know which one of these is ZR. So look at this diagram now. To go from Z to R, I can go Z to Y, and then Y to R. If you notice, they're giving these answers in terms of the WX and the WZ, right? So we have to realize on this is that WZ is same as XY. All right? Our Y to R is a negative half of WZ. See that? Our WZ and XY is the same. But see the YR here so is actually minus half of that. Because the whole of this up here so would be WZ same way. And this is negative half of WZ. So this is negative half of WZ. That's what this is, the YR. And then now, this ZY is the same as WX. This is the same as WX. So this ZY is the same as WX. So that's what they're looking for in this question. WX minus half WZ. WX minus half WC. WX minus half WC. That's it. All right, so the opposite vectors, opposite sides are equal vectors. Yeah. On here, similar question. So it gives us that diagram. It says this vector is V down here, so you automatically know that this whole vector is V as well. But this is the midpoint of this side. So the whole thing is V. Then from here to here, coming down is half of V. And from here to here, coming down is another half of V. And if this vector is U, then the vector across here, going this way, is also U. The question I want to know, the vector WR. WR. So WR clearly becomes U minus half V. See that? U minus half V. So it's clearly U across here. And then why is it minus half V? Because you're going in the opposite direction to the half V. So U minus half V. It becomes U minus half of V. First one. Next question. Another similar question. Give us the parallelogram again. So this vector is K. It means that right here, so it's also K going that way. The vector coming down here, so is M. The vector coming down here is also M. Opposite sides are equal vectors, guys, in a parallelogram. What is EG? Is it this one EG? So it's obviously it is K plus M or M plus K, don't it? Which one is there? K plus M. Same thing. Over here. OQ is A and QR is B. They want PN. L is the midpoint of right here. They want PL. They want PL. PL is half of PR, don't it? So all right, PL is half of PR. What is PR? From P to R. P to R is minus A plus B. Can you see that? Why is it minus A? Because going opposite direction to A, don't it? So it becomes half of minus A plus B. And minus A plus B, same as B minus A, right? So it becomes half of B minus A. Half of B minus A. B minus A over 2. B minus A over 2. That is it. Very good. All right. Next one down here. This question gives us the diagram again, gives us information up here. So it tells us that OR is 3A minus 2. It says R is the midpoint of OL right here, and OR is this vector. OR is this vector right here. So it gives us OR. So it means that OL is 2 times this, right? OL is 2 times this, but L is the midpoint. And it also gives us the vector OM out here in terms of A and B. All right. I don't remember seeing this question. Question wants us to find LM. LM. So to go from L to M, we can just use O times the last minus O times the first. So LM is OM minus OL, right? Watch this now. OR is this. So OL is 2 times OR, don't it? OL is 2 times OR. So OL becomes 2 times this, which is 6A minus 4B, don't it? And so if you want to find OM now, the OM is what they gave us right here. 2A plus B, so this is 2A plus 3B, not B. 2A plus 3B minus this. Care for the bracket now, put in a bracket. 6A minus 4B, it's in a bracket. Expand the bracket on this now, you're going to get 2A plus 3B minus the 6A, but the minus make this a plus 4B now. Plus 4B. consolidate now. The A values first. This time it become minus 4A. Minus 4A. And the B value becomes 7B plus 7B. So it's 7B minus 4A. See here? Now this can be spun around and be written as 7B minus 4A, which is this answer right here. All right, nice question that one, not bad. Similar question here. They say OR is A, OT is B, and R is the midpoint of this side and T is the midpoint of that side. So clearly then, if OR is A and this is the midpoint, means that up here is another A, don't it? And if this is the midpoint to here, and that is B, then this is another B over here, right? So this is 2B and that is 2A. So the question wants us to find RM. RM. So clearly, RM is OM minus OR. O times the last minus O times the first. The OM is 2B out here, so 2B. And the OR is just A right here. So it's 2B minus A, first answer. That is it. Similar question now, same diagram, but another one, LM. Another one, LM. LM is just OM minus OL. The OM is the same 2B out here, so. And the OL is 2A. So it's 2B minus 2A. 2B minus 2A. 2B minus 2A. This factorizes it, I put it like this. So I factorize the 2 into B minus A. So it's 2 into B minus A. Use that. We're done. And we are done. Huh? Yeah. There are vectors question upon the past for them. All right. We have 20 more minutes. Let's look at them. We have 20 more minutes. Let's use up the 20 minutes that we have. So let's look at the January 2026. Huh? You want to try something serious? I just did this question, right? Just did this spot ground, right? I'm not sure so I think. I'm going to change it to now. They want to find EG. EG, escape process. And this is M down there, right? This one. 2P minus Q. Them question I repeat. Let's want to look for the one that will repeat, right? All right, so one here, so. Or is it major series? Huh? You like what? It's a major seed. I think we've been through this already. All that's gonna happen, guys, is that this P equal to 3 there, right? And Q plus 2 equals 1. That's all. And then this S minus 1 equals 2. So S equals 3 and get the values easily like that. That the matrix here that equal a matrix, the corresponding values equal. So P equals 3. Q plus 2 equals 1. So therefore Q is negative 1. S minus 1 equals 2. So S equals 3. That's all for that one. I don't see any more vectors than this. But there are measurements questions than it in a bunch. So we do have some of these questions already. This question down here says, based on the diagram, the bearing of E from F. E from F. E from F is this bearing. This on the right is right. See, and you put the 0 in front of it. This one is that these we did already. Already saw a while ago. So that one. So you see the questions repeat a lot, guys. Repeat a lot. What about this question? What about this question? So I did this question and I sent it in the group. I'm not sure if I send this paper in the group. So I'm going to send this solution for this paper in the group just in case. Huh? The January 2021. So the question for this one says, must read which are these statements. Say, based on the graph, which are the following statement about the cycles is true. So this is the speed graph, speed time graph of a cyclist on a journey, right? All the information is there. Which one of the statement is true? The answer for this one is D. It says from rest, start from rest. Let's look at the first one and see why it's wrong. Cyclist accelerate at 0.1 meters per second for 50 seconds. That's the first part, 50 seconds. We'll have to check the acceleration if it's correct. Acceleration is great then. It rest for 1 night. No, it never rests. So this is what makes it wrong. Because it did not rest. Even if the acceleration is right, it did not rest. Up here, so you're traveling at a constant speed. Rest means that you're not moving. Rest is when you don't move, so when the speed is 0. These are the two places that rest. Not moving, speed is 0. So this makes it wrong up here. This up here makes it wrong. Did not rest. So this makes it wrong. Did not rest. That makes it wrong. Second one, the cycle start at a constant speed. No, start at 0. So this makes it wrong. Never start at a constant speed. So this makes it wrong. From rest, the cycle is decent. No, the cycle didn't decelerate, it accelerates. So this statement right here makes this wrong. This statement makes it wrong. So that's like the last one. From rest, from rest, the cycles accelerate at a constant rate. Yes, constant rate because that's a straight line we have on the graph. So it's one constant gradient. To a speed of 6 meters per second after 50 seconds. See there, yes, true. You reach a speed of 6 meters per second after, see there, 50 seconds down there. So, all right, which is true. It says, after 50 seconds, maintain the speed for 190 seconds. So that's 190. Only is 190 because it's 240 minus 50. So that's 190. And it maintains that speed. Up here is holding that constant speed of 6 for that length of time. What else it says? Then it says, then decelerates the rest in 30 seconds. Yes. From here to here, this is 217. From 240 to 270 at 30 seconds, and here to decelerating. Speed is cutting. So this is the last one that is the correct answer. Watch this now. If this ever give about this diagram, and I ask the questions like, what's the acceleration? Gonna be this gradient here, so which will be the rise of 6 over the run of 50. That will be this acceleration. Gradient over gradient, which is rise over run. The ask for the deceleration, it will be the fall on this side. Fall of 6 over the run of 30. That will be the deceleration. Fall of 6 over the run of 30. That gives you the deceleration. The question should ever ask for the deceleration. If they ask for distance travel, it's the area under the graph. You don't want it, if you don't want the distance travel when it is accelerating, you just area this triangle right here. So You don't want the air this time when it's traveling at a constant speed. Let's say you have this rectangle inside. So remember, distance equals area. You don't want the distance travel while it is decelerating, it's the area inside this triangle. It is decelerating down here. Alright? Stuff like that. You don't want the average speed for the whole journey, then the total, you want the total distance traveled in the total area of everything, which is area trapezium. Half the sum of the parallel sides times the distance between the parallel sides, which is 6. You're gonna have these two sides. This is 190 up here, so, and this is 270 down here, so. The distance between them is 6. So the distance would be half the 190 plus the 270 and the 6 between them. That will be the distance traveled if they wanted that. And we want the average speed, we're going to put this distance now over the total time of 270. All right, I think the solution, I'm going to send the solution, and I put some additional stuff on it that I'm talking to you about now. On the questions. I'm going to send it in the group so you can see it. All right, let me see if I can find the solution and show you. All right, question. So, see, this is it. So, I gave you all those things a while ago. Oh. I'm tired, Mr. Shaw. Tired. Coming to the end of my journey in this class. So much distinction may I get. See if Sina will bless me up with a distinction. See if Sina will bless me up with a distinction. Not this way. Around paper, me having January 2026 solutions here. See if Sina will bless me up with a straight in. What that sound, Sina? Sina got this, man. Straight A's. I don't want to think of Sina alone. That's about Sina what that sound. See it here, guys. So I did some work. I did some work on it. I want to send to the group. So I worked out some additional stuff on it, just in case. All right, just to show you. So work out the average speed and the distance and all them things down there. So work out some additional stuff down here. You just should ask those additional stuff. So I'm gonna send this in the group so you can see, you know, how you would work this out. Don't want it. All righty. That is it. So tomorrow, last lap. Gonna do 5 papers tomorrow. No, I'm not printing the paper. I'm very serious. I'm not printing the paper. Bring your device. Bring your device. I'm not printing the paper at all. I'm not even going to wear no printer is. I'm not even going to wear no printer is tomorrow. So forget it. I'm not even going to wear the printer is tomorrow. Eh? Paper. Oh. All right. Guys, I want to focus on doing the most recent 5 exam papers at least. 2026 January, 2 papers from 2025, 2 papers from 2024. See, you can understand every single question on those papers. The solutions are in the group, right? Them in the group, I send them in the group. Over a lot of them here today, over the last 4 days. So tomorrow come, just last chance to bring your question, whatever question they don't understand from it to explain. All right, that's the plan for tomorrow. That's tomorrow. All right. Okay. All right, buddy. Oh no. A classroom. Right. Okay, my boss. Wait. Hello? Hello? That's it's yan and look there. Eventually na no yes. Huh? Yeah, man, what's up? I'm trying to get something like that on the phone. I drive on there. Them have one road, I think there, them have one on the ear circle that all. Are them busy at all? Eh? Are we not ear circle at all? Oh, you know, that's just like our next connection or they get like that's like our phone. Now, of course, I can see them. I'm sure I go to contact with your past history, you go to that's what I understand. Just because I talk about national. Yeah, one to go on, by the top. Oh, yeah, that. It have more down the road, that's what I'm telling you. It have more down the stretch. Yeah, but I tell you which one. Oh. Which one to go? Not the first to go, I'm not going to go faster. Hello? I feel like I get much value out of them in class. I feel like I get as much value out of them in class that as well as I feel like I get much value. But the much just class. I don't get much value. Yeah. Yeah, but it's yeah, much. Come back, give it the other exam. 1-1. Next school tomorrow. Oh, I think actually, well, I think that your school start Thursday. So we're going to do it tomorrow. Where are we tomorrow? Yeah, to my school. But my job to my school, and I'm not in Sydney. Huh? So we can't go down. Are we going him? I can't go to school. And you get that daily ready. So first stay on the way down. The fuck. Keep him away from the sun the weekend. Yeah. Tell him our, tell him man no shoot. It's a yo. Good at it was. Well, this thing here was up on a get bread, man. That thing that was really bad for the day. Message. Second time, Mr. McDonald, Mr.